We picture the internet as a weightless, invisible cloud. But the reality is that every video stream, financial trade, and search query relies on massive, hyper-cooled physical warehouses packed with millions of servers. Right now, the explosive adoption of complex AI models is accelerating this reality. Training and running tools like ChatGPT or Claude requires an enormous amount of raw computational power, forcing a sudden and massive demand for physical space to house the necessary hardware. We are hitting a hard collision. The core promise of the digital economy, infinite, frictionless software scalability, is slamming into the highly finite limits of land, electricity, and water. The software side of the tech industry cannot grow any faster than the concrete and steel required to support it. The cloud has hard, physical breaking points. Navigating this physical bottleneck falls to two very distinct groups: enterprise IT leaders who need the computing power, and infrastructure investors who finance the actual buildings. For the enterprise leader, the problem is operational. They need to secure elite computing resources to keep up with competitors, but they want to do it by renting third-party servers so they don't bleed out their available cash buying their own hardware. For the investor, the problem is structural. They are looking at the guaranteed long-term growth of AI adoption, but they have to weigh that against the staggering capital costs and severe environmental risks of actually pouring the concrete and connecting the power lines. This decision tree maps out the two analytical paths we need to follow to evaluate the economics of this industry. Path A covers the business IT strategy, and Path B covers infrastructure investment. You cannot judge the data center boom as a single, uniform topic. Your trade-offs depend entirely on whether you are the tenant renting the space or the landlord funding the facility. Let's start with the business perspective. 10 years ago, the baseline for a growing company was an on-premise server room. You bought the hardware, you maintained it, and you paid for the power. Moving to a data center shifts that entire financial model. You go from unpredictable, massive capital expenditures, buying $1 million worth of servers up front, to predictable operational expenditures, paying a monthly fee for the exact computing power you use. If your e-commerce site gets a sudden spike in traffic over a holiday weekend, you don't have to scramble to order and install new physical servers. You simply provision more virtual resources instantly from the data center and scale it back down when the rush is over. Looking at this comparison matrix, the immediate appeal is clear. The data center model completely eliminates the heavy upfront hardware costs and provides near-instant flexibility, outscoring the on-premise model significantly on scalability. But here we see the primary trap: cloud sprawl. Because scaling up is frictionless, departments easily lose track of the rented resources they've left running. The friction of buying physical servers is gone, leading to heavily optimized operations, but unexpectedly bloated monthly bills. Renting data center space perfectly solves the burden of upfront hardware costs. In exchange, it introduces a dangerous, ongoing budget management risk that requires constant auditing. Beyond cost, an enterprise relies on its servers staying online. If a banking app or hospital network goes down, customer trust evaporates immediately. Most modern enterprises require a 99.99% operational uptime. To guarantee that uptime, commercial data centers are built with a scale of redundancy a normal business could never afford. They utilize dual power grids, multiple fiber optic internet routes, and industrial backup generators that can run the entire facility during a total blackout. That level of operational safety comes with a severe trade-off. By moving your data off-site, you are surrendering physical sovereignty over your hardware to an external vendor. Centralizing the data of thousands of different companies into one physical location creates an incredibly high-value target for cyber attacks. A single physical or digital breach at the facility level can instantly expose the proprietary data of millions of third-party end users. The facility mathematically guarantees your structural uptime, but to get that guarantee, you have to permanently surrender absolute security and control to an external party. Switching to the infrastructure investor, the mechanics of this boom look entirely different. This is the group actively funding the concrete and copper required for the 2026 AI expansion. The exponential adoption curve of high-compute AI models practically guarantees long-term tenant demand. If you build a facility capable of handling high-density AI servers, major tech companies are waiting to sign multi-year leases to fill it. But the financial barrier to entry is immense. Securing appropriately zoned land, importing specialized cooling hardware, and securing industrial-scale grid access requires staggering amounts of upfront capital. This quadrant chart plots the tension in the market. On the vertical axis, we have the explosive growth drivers of AI and cloud demand. On the horizontal axis, we have the harsh physical limiters throttling construction, specifically capital and energy. Highlighting the upper right quadrant, we see that these extreme costs create deep economic moats protecting existing large-cap builders. However, it also forces incredibly long ROI horizons that stretch or contract depending heavily on macroeconomic interest rates. The sheer cost of building a modern data center locks out new competition and protects established infrastructure funds. But those same costs leave their long-term yields highly vulnerable to sudden shifts in the cost of borrowing money. The most rigid constraints facing builders today aren't financial at all. They are regional energy grids and local water supplies. A single, modern, hyperscale data center now demands as much electricity as a small city. In areas with high concentrations of these facilities, they are pushing local power grids to the brink of failure, leaving local governments scrambling to manage the load. The servers required for AI run exceptionally hot. They require specialized liquid cooling systems that pull immense amounts of water from local municipalities, triggering immediate resistance in drought-prone or agriculture-heavy regions. This environmental strain results in aggressive regulatory backlash. City councils are increasingly issuing zoning denials, and states are imposing strict environmental caps on new infrastructure developments. The ultimate ceiling on the AI boom isn't a lack of technological demand. The ceiling is the total exhaustion of local physical resources and regulatory goodwill. Let's review this target audience scorecard, starting with enterprise decision-makers. You fall into the Proceed profile if you run a rapidly scaling enterprise, a highly seasonal business, or if you are integrating intensive AI tools. You need elite computing resources immediately without destroying your cash flow through heavy CapEx hardware purchases. You fall into the Pause profile if your organization handles highly classified data or protected health information, where absolute physical air gapping is a strict legal mandate. If you cannot afford to share a physical facility with another company, you must keep your servers in-house. For the modern enterprise, outsourcing to a data center is the mandatory default for maintaining growth, unless absolute physical isolation is legally required by your industry. Finally, looking at this scorecard for infrastructure and tech investors, the risk profile shifts. The perceived criteria apply to long-term infrastructure plays. This is ideal if you want to capitalize on the foundational hardware layer of the AI boom, recognizing that the software requires a physical landlord. The Pause criteria apply to portfolios highly sensitive to short-term interest rate spikes or funds bound by strict ESG mandates regarding water consumption and regional energy depletion. The digital economy is completely bottlenecked by concrete, water, and copper wire. Whether you are deciding how to scale your business operations or deciding where to allocate infrastructure capital, if you aren't factoring these hard physical constraints into your digital strategy, you are already falling behind.